In this video, we're going to discuss how to take the determinant of a square matrix of any size. So if A is a square matrix of dimension 2 by 2 or greater, then the determinant of A is the sum of the entries in any row or column of A multiplied by their respective cofactors. That is, if you were to expand along the first row of the matrix, let's say we had some matrix, or some n by n matrix, so A11, A12, etc., down to A1n, A21, A22, A2n, so on and so forth. A2, so this would be AN1, AN2, ANN, right? Okay. So say we have that. Well, we could expand down the first row. If we do the first row, that would be, we could find the determinant as A equals A11 times the first cofactor plus A12 times the second cofactor, and just keep going up to A1n times C1n, okay? Here, or another way we could do it, and these will all give A, we could go down the second column, right? A21, C2, or second row, sorry, plus A22, C22, and then all the way down to, since we're going down this, A2n, C2n. Although what I said before was correct as well, we could go down the second column because it's down any row or column, okay? So we could actually do it that way. We could go down that way and have A12, C22, C12, sorry, plus, this was 2-1 by the way right there, plus A22, C22, and then go all the way down to AN2, CN2. All right? And so we can just go through expanding that way. And in fact, that actually tells us why this is called expanding by cofactors. Or sometimes people call it expansion by minors, or expansion by minors. Okay? Because there's minors as well. But the most important thing to realize here is that you have options, okay? Which gives us lots of possibilities of how to do this, okay? So for example, what if we wanted to find the determinant of the following matrix? Well, we can find this by going through and doing the cofactors. I'm going to go ahead and do this a different way though, since I don't have to find all the possible cofactors, okay? Really, that was more useful for the concept. The minors and cofactors are much more useful in the background than they are here, than they are in practice. So what I'm going to do is I'm going to go ahead and expand down. I have options here. I'm going to go ahead and just expand along the top row. Okay? If I do so, then I would have, I'll say expand along top row. If I expand along the top row, then I have the following. I get 0 times, and here I have 0 times the minor that would be formed from deleting zeros. So -1, 2, 2, 0, 1. Then I'm going to go ahead and I'm going to subtract. Now, why am I subtracting instead of adding? Well, what I'm doing here is I'm calculating my cofactors by doing the minors as I go along. And I know that this is a plus, minus, plus, minus, plus, minus, plus, minus, plus from our last video. Okay? And so, as such, what we have is that we get a negative, because of the negative there, that's why we have the negative there, we have a negative there, okay? So, namely, this right here is my C11, this was my A11. This together, so I have 2, and then I have the minor 3, 2, 4, 1. These together will give me my C12, where this was A12. Well, then I add 1, and then the minor, which will also be the cofactor because of the positive sign involved, to get C13, which will be 3, the determinant of 3, negative 1, 4, 0. Okay? So doing so, we notice something nice here. It doesn't really matter what this determinant is because, well, we'll have 0 times negative 1 times that, so negative 1 minus 0. I'll write it that way. But it doesn't really matter what this is because that's going to 0 out. And here we have 2 times, we'll have 2, so minus 2 times 3 minus 8, write it that way, plus 1, I'll just drop that, 0 minus negative 4, so plus 4. So what do we have here? Well, that's 0, that's going to be 2, 3 minus 8 is 3 minus 8 is negative 5, so negative 5 and negative 2 is plus 10. And then plus 4. So we end up with 14. Now, as I said before, it doesn't matter which row or column you go down. So we could go down this row or that row expanding, or we could go down any of the columns. For instance, if we go down this column, we would have negative 2 times 3, 2, 4, 1. 3, 2, 4, 1. Minus 1, okay, plus negative 1, so minus 1, times 0, 1, 4, 1. And then I'm going to have 0 at the end, but it doesn't really matter what the minor is because 0 times anything is 0. Which tells you, which actually gives you a big hint as to why it's good of how to choose which one to go. Again, you can choose any row or column, but since you have the options to do that for your expansion, it's good to pick zeros, rows or columns that have a lot of zeros in them, because then you have less that you have to calculate. So this is negative 2 times 3 minus 8 minus 1 times 0 minus 4. And so we have negative 2 times 3 minus 8 is what? 3 minus 8 is negative 5 times negative 2 is 10. And then that's going to be negative 1 times 4, so plus 4. So again, we get 14. And that should not be a surprise because we will get the same answer no matter which row or column we choose to expand. Now it's your turn to try an example. So go ahead and find the determinant of the following matrix A. Keep in mind that it's good to try to pick a row or a column that has a 0 in it, okay? Hint, hint. And on the count of 3, I'll reveal the solution. 1, 2, 3. So here you have 2 good options. You can either expand along the second row because there's a 0 in it, or down the third column because, again, 0. Those are the 2 best options. Again, you also have the other options of any of the other rows or columns to expand. But when you go through and you do this, you get zeros, and that makes it easier. And either way, you'll end up with negative 31. So let's put to the test what we've already learned. Here, we can keep going the same way. So bigger matrices, this can become a longer process. Namely, here the best one to go down is this one for find the determinant of this matrix. So the determinant of A will be, so here let's be careful, we have plus, minus, plus, minus, minus, plus, minus, plus, plus, minus, plus, minus, minus, plus, minus, plus. And notice you just start at a plus here and then fill out the whole matrix when building your signs. Here, so this is the best one because it has the most zeros. Namely, we see that we'll be expanding there. And so we have positive 3 times the determinant of this matrix, which will be negative 1, 1, 2. So our minor is a big one this time. 0, 2, 3, 3, 4, 2. But what's nice about this is at first you're like, oh, that's going to be a bunch of 3 by 3 matrices, and each of those will involve a bunch of 2 by 2s that I got to take determinants of, and this is going to get huge. Well, yes, but that's why we're picking zeros, right? Because now we're going to have minus 0 plus 0 minus 0, because none of those determinants will matter. So that helps out a lot. Here, we can again be careful of how we choose it. Let's go ahead just for sign preference. I'm going to do down the first column. So we have 3. I could also do the second row. I'm just trying to exploit a 0. So that's going to be 3 times the determinant of expanding down that way. So that's going to be negative 1 times the determinant of 2, 3, 4, 2 plus, or minus, I guess, because of the minus. Yeah, because this one now is plus, minus, plus, minus, plus, minus, plus, minus, plus, right? And so we're going to have negative, so positive, negative, positive, so minus 0 plus 3 times 1, 2, 2, 3. All right. And so now we just got to expand all this out. So 3 times negative 1, 4 times, we'll do it this way. We'll do 4 minus 12 is negative 8. And then this will be plus 3 times 3 minus 4 is negative 1. And thus we end up with 3 times 8 minus 3, which will be 3 times 5, which is 15. And now it's your turn to test your knowledge. Go ahead and calculate the determinant of the matrix A. On the count of 3, I will reveal the solution. 1, 2, 3. So here we go through and we expand along the third column because that has the most zeros in it. Doing so, we only end up with 2 entries because it would be a 0 and a 0 here. So I just didn't even bother writing them. Here I went ahead and for each of the 3 by 3 determinants, I did the first column expanding. Then there's all these 2 by 2s you got to evaluate. So I go through and I do that. And it's just a numbers game of doing all the computations. For more practice in computing determinants, be sure to see page 582 and 583 of the textbook. In our next video, we're going to start seeing some applications of determinants and of matrices as well by considering Cramer's rule.